All right. Thank you, Rohit. Now we have spent a lot of time on models so far. And that's important because models are at the center of all this excitement. But there are a few big areas where agentic applications differ from traditional software. First is decomposition. Agents take higher level objectives as inputs, and they decompose them into plans and any required code necessary to solve the problem. Unlike traditional static apps, where they will execute step by step, agents are different. They are dynamic, and they change during runtime. Second is self-reflection. Rather than running through their instructions from start to finish like a pipeline, they self-reflect and until they have reached a desired goal, changing their tactics as and when needed. And third is action and tool use. Whether that's performing actions in other systems like making API requests or being able to access data and even call other agents like Noah Act, that may be specialized to do particular tasks that is necessary for achieving the overall goal. So what does this mean for how we build agentic software? Well, to put simply, agents demand new tools and frameworks for builders. Many of our customers have built and experimented with agents using Bedrock, and we have learned a lot from your feedback. And one thing we have learned is that you want more control and the ability to more easily use open frameworks with AWS. These open frameworks take the heavy lifting out of orchestrating these agentic applications. We have seen a lot of momentum around frameworks like Crew AI, LangGraph, and Llama Index. We have also released Strands Agents SDK, an open source framework that delivers a simple, modern-driven approach to building agents. Compared with other frameworks that require developers to define their complex workflows for their agents, Strands is different. It simplifies agent development by embracing the capabilities of the state-of-the-art reasoning models to plan, chain their thoughts, call tools, and self-reflect. Strands Agent is provider agnostic, while also having native tools, MCP servers, and integration with AWS services out of the box. And just yesterday, we released Strands Agent 1.0, which brings new capabilities for building multi-agent systems, including A2A support, data persistence for agent conversation, and multi-agent workflows. We have seen strong support for Strands agents from the model provider community. Anthropic, Cohere, Meta, Mistral, 12 Labs, Stability, and Writer have made contributions which enable more nuanced support for their model APIs to be used by a Strands agent. And it's not just about frameworks. You need these agents to be interoperable, both with the tools they use as well as other agents. Here is where emerging standards like MCP and A2A come in. They are tackling this challenge with broad adoption from industry leaders like Anthropic, Meta, and Google. These protocols help us connect agentic apps or models to data sources, tools, memory banks, and more. Instead of having every app developer write connections for each destination, the provider writes an MCP for their own interface, and it allows agents to interact with it. At AWS, we are really leaning in here. We are on the steering committee for both MCP and A2A projects, bringing our decades of expertise in distributed systems at Amazon to improve these protocols. For MCP, several core components in the latest spec were designed and contributed by AWS. Now, despite all of these open source frameworks and protocols, getting agents to production is still too hard. This is because of the dynamic and autonomous nature of agents and the effect it has on how you build and operate them. So we took a look at what you need to be able to deploy agents to production. First, there is figuring out how to securely execute and scale the agent code. This involves building, configuring, and scaling a runtime and execution environment that can handle all the dynamic agent code and workloads. And it's not just about scaling compute. You also need to maintain guarantees around security and isolation, so that data from one instance of the agent does not lead to another. Then you need a way for agents to remember their past interactions and learn to improve over time, allowing them to be truly personalized. Storing memory for agents is not as simple as storing a traditional app state into a database. It requires supporting not just high-performance logging of short-term activities, but also mapping these extremely long contexts to higher-level concepts that the agents learn over time. Next is enabling agents to interact with true autonomy on behalf of user and systems. Doing this the right way requires identity and access control for our agents, tools, data sources, and beyond. Fine-grained access controls enable agents to only access the systems and data sources you allow them to do so, such as specific API call for actions, subset of tables in a database, and more. Next, agents are as valuable as the actions they can take. To help with this, they need to be able to use a number of common agentic tools. One example of this is being able to use code to perform tasks that foundational models haven't been pre-programmed to do, like complex math calculations. Doing this requires generating and executing code in a secure manner in a way that does not interfere with the original agent code itself, or allowing the agent to interact with common interfaces. Here, a use of a browser changes what's possible, enabling agents to take action in the digital world, whether that's consuming data from the web or taking actions on a website by filling a form. But there are a whole host of common tools agents need to discover and connect to. This includes tools for taking actions or just for consuming data, whether that's sourced within an organization or outside the organization. Then there is the challenge for agents discovering and understanding which of these tools they need to use for their task at a given moment. And finally, we need deep auditability and understanding of the actions our agents are taking. Complex, multi-step agentic workflows are even more challenging to debug than traditional software. If something fails, it is absolutely critical to understand why, not just where they fail. Here, we need telemetry and observability for every interaction in their workflow, including the intermediate steps. As you can see, today there are a bunch of missing pieces that make it really difficult from moving from POCs that are sitting in laptops to agents in real-world production use cases. And all of this work to tie your agent together for a single combination of one framework, one model, and one set of tools doesn't stop there. You need to do this all over again when the business use case changes, or you want to use a different model, or new frameworks come up. All this muck is slowing down customers and preventing them from getting agents into production quickly. So we took a look at this entire end-to-end problem and asked ourselves, how could we make this faster and easier for you? That's why today I am excited to announce Amazon Bedrock Agent Core, a set of services to deploy and operate capable agents securely at scale using any framework or model. Agent Core is a step change for moving your agents from POC to production with scale, reliability, and security that are critical for real-world deployment. It provides tools and capabilities to make agents more effective and more capable, purpose-built infra to securely scale agents, and provide the controls to enable you to build trustworthy agents. Agent Core services can be used together or independently, giving developers the ultimate flexibility they need. Let me show you with an example how Agent Core addresses each of these before I dive into them. To begin with, first, there is the ability to securely scale agents. Agent Core Runtime is a secure serverless runtime purpose-built for deploying and scaling dynamic AI agents and tools, regardless of frameworks, protocol, or model choice. Developers can securely and reliably run any type of agents, including multimodal, real-time, or long-running agents, with workloads running up to 8 hours, the longest in the industry. Runtime is highly reliable with checkpointing and recovery capabilities built in to support graceful recovery in case of unexpected interruptions and failures. And it can scale up to thousands of agent invocation sessions in just seconds. Runtime is secure by design with built-in identity controls, and it is the only runtime available today with complete session isolation, not just like a process isolation, providing dedicated compute environments per session with complete memory isolation to help prevent data leaks across agents. Second is handling full management of memory systems with agent core memory. Agent core memory makes it easy for developers to build context-aware agents. Memory provides industry-leading accuracy, along with support for both short-term memory for multi-turn conversations and long-term memory that persists across user sessions, with the ability to share memory stores across collaborating agents. Now, developers can just focus on building intelligent agents rather than managing these memory systems. With this memory service, there is a lot of clever management of how memories are formed and managed automatically under the hood. Let me show you. As humans, we have a short-term memory that is really fine-grained and kept in relatively small size, storing data like what I had for breakfast this morning. Then we have long-term memory, which is a lot less granular, but is efficient, mapping higher-level concepts all together like what my favorite foods are. Over time, the brain does a lot of work to take these frequent short-term memories and encode them into longer-term memories. And over many years, the brain constantly rewires their neurons, even for those long-term memories, causing them to get recompacted over and over again, preserving what's important in an efficient way. Memory service works very similarly. This is all done automatically for you under the cover with a single memory endpoint. Next, agents need to securely access other agents and tools. This is where, with Agent Core Identity, we provide secure, centralized access management for AI agents, enabling seamless integration with AWS resources and third-party services. We simplify secure and delegated access for agents by providing each agent with a unique identity. This distinct identity enables agents to operate with appropriate security controls and proper authorization across different systems like GitHub or Salesforce. Agent Core works with your existing identity providers, including Amazon Cognito, Okta, Microsoft Entra ID, and others, so there is no need to migrate your users or rebuild your authentication flows. For agent builders, we simplify access to third-party services by securely managing API keys and OAuth client credentials. Next, we build tools that are critical for many agentic workloads. For writing code to enhance agents' accuracy and expanding their ability to solve complex end-to-end tasks, we have built Agent Core Code Interpreter. Code Interpreter tool enables AI agents to write and execute code securely in their own sandbox environment. It comes with pre-built runtimes for multiple languages and advanced features such as large file support and internet access. And developers can customize their environments with specific instance types and session properties to help meet their security requirements. The second agentic tool is Agent Core Browser Tool. This provides a fast, secure, scalable, cloud-based browser to enable AI agents to interact with websites at scale. While most browser tools out there are tied to a specific model, such as Sonnet 3.5, 3.7, or OpenAI's computer use preview, Agent Core Browser Tool is model agnostic. It includes enterprise-grade security features, including VM-level isolation and federated identity integration, critical for carrying out tasks that require embedding secrets natively. Then agents need to call all sorts of tools and data sources to execute their workflow. And for this, we have Agent Core Gateway. Gateway provides an easy and secure way for developers to build, deploy, discover, and connect to tools and agents at scale. Developers can convert their existing APIs, Lambda functions, and existing services into MCP-compatible tools and make them available to agents through Gateway endpoints with just a few lines of code. Gateway even provides one-click integration with several popular tools such as Salesforce, Slack, Jira, Asana, and Zendesk. For input types, Gateway supports OpenAPI, Smithy, and AWS Lambda. And as your tool collection grows, agents can find and use the right tools faster through built-in semantic search capabilities. And because you need a secure way to do this, it automatically connects into our identity service. Finally, Agent Core Observability helps developers trace, debug, and monitor agent performance. It offers detailed visualizations of each step in the agent workflow, enabling developers to deeply inspect into an agent's execution path, audit all their intermediate outputs, and debug performance bottlenecks and failures. Observability gives developers real-time visibility into agent operational performance through built-in dashboards by CloudWatch, and telemetry for key metrics such as session count, latency, duration, and error rates. Agent Core emits telemetry data in open telemetry format so that enabling customers to easily integrate with their existing monitoring and observability stack. Okay, now we have all of these primitives. Let's take a look at an example of Agent Core in action. For this example, we are going to build an agentic loan processor, one that accelerates risk analysis based on credit and other data before passing to a human to finalize. Our proof of concept already uses the Crew AI framework to compose a crew of 3 agents running across multiple hosting providers, not just on Bedrock or on AWS. First is an intake agent that can organize loan application data. Second is a credit agent that can analyze creditworthiness and calculate risk metrics. And for third, there is an underwriting agent, which takes all this analysis and writes a recommendation that is then passed off for a human to review. Now, let's use Agent Code to make our proof of concept ready for production. First, we will add memory. When we add memory to our agent, we simply give the memory group a name, description, and decide how long we want these memories to be stored, and add a memory strategy to help the model sort short-term memories into useful long-term memory categories. With this configured, our agent can now remember details from previous conversations and provide a very personalized experience. Next, we want our agents to utilize tools from across the organization. So we are going to add an Agent Core Gateway. Here, we will set the role for the agent to use and attach our authorization method, either using Agent Core Identity or an externally managed identity provider. Then we are going to add targets to the gateway. These are the specific resources we want the agent to be able to use. You will add a target for Lambda so that we can poll for updated payment data stored in Dynamo, or an S3 target to access historic loan documents we may have on file, and a gateway target for an external API that will enable the agents to do things like income verification. Next, we want the agent to handle any calculations the human underwriter might have. So for that, we are going to add Agent Core Code Interpreter. Now the underwriter agent will be able to perform analysis such as adjusting the weighting of the borrower's debt-to-income ratio. And then the agent can quickly create and execute the code that is needed to do this calculation. And now we are ready to deploy, where we will use the Agent Core Runtime secure serverless environment that can handle both real-time and long-running agent workloads, automatically scaling to meet demand. We just create a runtime instance, specify the endpoint, which in this case is a Python file for our agent. and runtime handles all the infrastructure, scaling, and security. Finally, we can use agent core observability to monitor how our agent is performing and get its insights into the health and usage. These dashboards enable us to debug problems across the agent's process. Like if our loan processor is taking a long time to calculate risk or to understand which edge cases are causing application ingestion to fail. And that's it. We have a fully production-ready agent deployed, secured, metered, and scaled, ready to help us transform our business, all with the freedom to innovate with models, frameworks, and data from anywhere. So this is Agent Core, a set of modular services that allows you to mix and match with everything you need for getting agents to production. And it represents a step function change in what is possible for AI agents. Now, building specialized AI agents in-house requires expertise across multiple domains, not just from large language models, but also with specific business functions. No organization can be an expert in everything, nor should they be. And just as today's software ecosystem thrives on third-party APIs, tomorrow's AI agents will need to integrate specialized capabilities from across organizations, providers, and systems. What is needed is a trusted source that brings together builders and buyers of AI capabilities in a centralized, secure, and governable way. So we asked ourselves, how could we enable this? Today, I'm excited to announce AI agents and tools in AWS Marketplace. Already, AWS Marketplace is your trusted source for discovering and deploying AI agent solutions from our expert AWS partner community and the world's leading AI providers. With this launch, you have access to a centralized catalog of AI agents, tools, solutions, and services from popular vendors. So you can benefit from a seamless API-based deployment using MCP and A2A. And deploy these pre-built agents and tools with Agent Core Runtime and Gateway. With this launch, AWS Marketplace now includes solutions and expertise from AWS partners like Anthropic, Salesforce, Deloitte, and others across areas like pre-built agents, agent tools including MCP servers, knowledge bases, guardrails, and many more, and professional services to help you develop and implement an AI strategy, and both agent development solutions for building your own agents and software solutions with embedded agentic capabilities. Together, Agent Core and AWS Marketplace enable more than the sum of their parts. Customers can deploy and scale Agent Core native pre-built agents and tools from Marketplace on Agent Core Runtime. And with just a few lines of code, you can allow your agents to securely connect to ready-to-integrate solutions from Marketplace with Agent Core Gateway. Now you can test and run AI agent solutions from a range of vendors, then quickly push to production and scale.